In this video, I want to prove one or two results that we came up with in the first video, namely that we can always write any cubic equation as x cubed equals px plus q, which is the form we need to use Cardano's formula. And secondly, why doesn't Cardano's formula work when we know that we have three equal roots? If I take any cubic equation, I can always divide the whole equation through by the coefficient of x cubed. I would then have an equation which had coefficient of x cubed as 1, and we might have anything bx squared plus cx plus d equals 0. So that represents basically the equation of any cubic equation. Now I'm going to put big X equal to little x minus b over 3. That will give us that x minus b over 3 cubed plus b times x minus b over 3 squared plus c times x minus b over 3 plus d equals 0. Expanding this, we get x cubed, remembering Pascal's triangle, plus 3x squared minus b over 3, that's 1, 3, 3, 1, plus 3x minus b over 3 squared plus minus b over 3 cubed. The next bracket, plus b x squared minus 2b squared over 3x plus b cubed over 9 plus cx minus bc over 3 plus d equals 0. The important thing here is that at this point we have minus bx squared, and here we have plus bx squared. So this is just x cubed. We have something times x, something times x, and something times x. Well, I can write that as minus some number times x. And then we have a constant term, a constant term, a constant term, and a constant term, and I can just write that as minus q is 0, which says that the equation we started with is now x cubed minus px minus q is 0, or x cubed equals px plus q. So if I can find a solution to this last equation, if I can find a solution to this equation here, all I've got to do is add b over 3, and I get back to x. So if I start with that equation, I know what b is, I solve this one, I add b over 3, I get back to my solution. So that's the first part of our problem done. Here, if we want to see what goes on when we have 3 real roots, if we look at the graph of y equals x cubed minus px minus q, if we're going to have 3 real roots, then the maximum must be a positive number, the minimum must be a negative number, and then the x-axis must cut the curve twice. Why don't you stop the video now, just pause it, and see if you can use that to decide why you cannot get the formula to work. Y1 has to be positive, Y2 has to be negative. Okay, just pause the video. Okay, this is how we do that then. We want first of all to get the stationary points, so that means we really want to have a look at dy by dx. dy by dx is 3x squared plus p, minus p, and that gives us, for stationary points, that x is equal to plus or minus the square root of p over 3. We do know that we've got stationary points because we want to have 3 distinct roots. Therefore, by implication, p must be bigger than 0. Right, let's take the first one. x1 equals minus root p over 3. That will give us that y1 is equal to minus root p over 3 cubed minus p times minus root p over 3 minus q. A little bit of algebra will tell us that this is actually equal to minus q plus 2 root p over 3 cubed. You might have to think about that for yourself for a little while. It basically hinges on the fact that p root p over 3 is equal to 3p over 3, which is 3 times root p over 3 squared root p over 3, which is root p over 3 cubed times 3. Don't worry if you didn't really pick that up. Okay, x2 is plus p over 3 square rooted, which gives me that y2 is root p over 3 cubed minus p root p over 3 minus q, which equals minus q minus 2 root p over 3 cubed. Now, in order to sort this out, I want to look at y1 times y2. y1 times y2 is minus q plus 2 root p over 3 cubed times minus q minus 2 root p over 3 cubed. Let's make that just a little tidier. This is just a minus b times a plus b, so that is a squared minus b squared. Root times root disappears. I'm just left with 4p over 3 cubed. And that, if I take the 4 out, gives me 4 times q over 2 squared minus p over 3 cubed. And if you look carefully at the formula, you will see that what we have down here q over 2 squared minus p over 3 cubed is exactly what appears underneath the square root sign. So if y1 is positive and y2 is negative, y1 times y2 will be negative, y1 times y2 will be negative, the expression under the square root sign will be negative. In other words, if we have 1 to 3 roots, 3 distinct roots, we must have y1 times y2 negative. We must have a negative number underneath the square root sign. So that is why Cardano's solution doesn't work when we have 3 distinct roots. In the next video, we'll start looking at complex numbers and the algebra behind complex numbers, how we handle them.